Good afternoon, everyone. I am Jana Hexter. I'm with the Northeastern IPM Center, and it's a beautiful June day here in Ithaca, New York. Finally, it has stopped raining for a few days, and I am excited to welcome you today on a presentation, Eco-Friendly IPM Approaches for Codling Moth Management. And before I introduce you to our guest speaker, I'm going to go through a little few housekeeping things. So this presentation was funded through the Northeastern IPM Center through a grant from USDA NIFR, Crop Protection and Pest Management Regional Coordination Program. And this is being transcribed. So if you would like to see a transcription, if you just scroll on your menu bar, you should see an option for choosing for transcription. It is being recorded and it will be posted on our website in about a week. And this is the link here, but you don't need to save it because I will email everybody who is registered for this webinar today. We would love your questions. AJ has split this presentation up into 5 sections. He's going to stop at the end of each section for your questions. So please feel free to pop those. And it's most helpful for me if you can use the Q&A feature rather than the chat, because it's harder for me to keep track of chat. So if you click on your menu bar for Zoom, which if you scroll your mouse at the top of the bottom, a black bar should pop up. And one of those options should be a box with 2 boxes that says Q&A. If you click on there, you can ask a question, and you can also do so anonymously. So feel free to do that. So I'm delighted to introduce our presenter today, whose little bio has lots of words that I may twist my tongue around. So I am not a scientist, and I don't have a degree in plant and soil sciences. So you'll have to excuse me if I mess it up. So AJ Pratap Giri is a doctoral research student or PhD candidate at the Stockbridge School of Agriculture at the University of Massachusetts in Amherst. His doctoral research focuses on evaluating eco-friendly biocidal drift reduction adjuvants using essential oil emulsions. AJ holds a master's degree in plants and soil science from UMass Amherst, where he studied the attractiveness of semiochemicals to multiple torticid pests in apple orchards. He's published 7 peer-reviewed journal articles and more than 15 extension articles, contributing significantly to the advancement of sustainable agriculture and integrated pest management. With extensive experience in applied research, extension, and outreach, his work primarily supports innovative and eco-friendly pest management strategies. So welcome, AJ. It is lovely to have you here. And I realize I mispronounced it. It's AJ Giri, not Giri. So there we go.
That's good. Yeah.
All right. So before we begin, you will see a poll popping up on your screen. If it doesn't pop up on your screen, if you're on a phone or a laptop or something that it doesn't pop up, do not worry about it. But you should see 3 quick questions. And this will help AJ have a better understanding of who is on the call and how he might tailor his presentation to your needs. So I will be quiet while that happens. All right. Well, 90% of people have answered the poll, so I will end that. I will share the results. We have about 20% farmer grower, 30% extension, 7% students, and then a smattering of other folks who are interested in this topic. How knowledgeable are you about eco-friendly IPM approaches for codling moth management? And the vast majority, almost 75%, not at all knowledgeable or somewhat knowledgeable. So, and then how knowledgeable are you about codling moth biology? Same there. We've got close to 80% of of people who are not at all knowledgeable or somewhat knowledgeable. So given that, it's perfect that you are here. It is perfect that AJ has been working and studying so hard for years to give you some great information. So with that, I will be quiet and turn it over to AJ.
Hello, everyone. Good afternoon, and thank you, Jenna, for the lovely introduction. And first of all, I'd like to thank the Northeastern IPM Center for the award and giving me the opportunity to present today. So I would like to welcome you all for today's talk on eco-friendly IPM approaches for cording moth management. So today we are going to cover cording moth biology, just a little bit introduction about the cording moth, and then the cording moth monitoring using lures and camera trap. And then we will discuss about biofix and degree model for cording moth. And then I will also discuss about a small study that I did with my SARE research grant, which is attract and kill system for cording moth. And lastly, I will also talk about residual effect of Bacillus thuringiensis, which is BT, against cording moth larvae. So just a brief introduction of cording moth. Cording moth is the major pest of apples and pear in North America. It is an invasive pest which entered North America back 200 years back. So cording moth belong to the order Lepidoptera and family Torticidae. So the family Torticidae has other moths that attack apples, such as oriental fruit moth, oblique-banded leaf roller, and red-banded leaf roller. And cording moth has up to 2 to 3 generations per season, depending on temperature and climatic condition. Let's talk about the life cycle. So it has the complete life cycle, meaning that it has all 4 stages: eggs, larva, pupa, and the adult. And so how the life cycle goes. So the cording moth overwinters as the overgrown larva inside a silken cocoon the whole winters. And during early spring, right around bloom, it pupates. And around late bloom, they start to fly. That's the time when you will start to capture them in your traps. And when they are flying, the female moth produces the sex pheromone that is detected by the male moth. So the male moth will fly upwind towards the female where the plume is being emitted. And once mated, the female moth will produce up to 70 eggs. And the eggs are laid singly, not in cluster. And the eggs can be laid on top of the leaf surface or directly on the fruit. And it takes about 6 to 14 days, depending on temperature, for the eggs to hatch. And once the eggs are hatched, the larva bores into the fruit. The larva stays inside the fruit up to 3 to 4 weeks, where it grows, eats the apple, molts several times, and when it turns into fifth instar larva, it comes out of the apple to pupate either on the bark or in the soil. So this is how they continue their life cycle. And as it says, like it is up to 2 to 3 generations per season. So do we have any questions on coding with biology?
I do.
That I can take?
Nope, we don't have any questions yet, so feel free
Okay,
to keep going. Okay.
sure. So now let's talk about the monitoring for coding moth. So why we do monitoring? So in order to detect the early infestation or when they first arrive, and it promotes the use of targeted pest control methods, and it also reduces the need for broad spectrum pesticides. So here I have the list of the lures that you can use for cording moth monitoring. The first one, this is by Trace, which is called Faircon Cording Moth Standard 1X. So the lure is loaded in this red septa rubber. It only lasts for 4 weeks and it's a standard lure. And the threshold is like 5 moths per week, 5 moths per trap per week. And if you are doing a mating disruption, so mating disruption is a way to confuse the male moth. So here in mating disruption, let's say you have a block, you are deploying these lures in high densities. so that the plume is coming from any direction. So the moth gets confused and it will not be mate, and the female moth remain unmated. That means they will lay the unfertilized eggs, and that way they don't cause damage. So in order to monitor the moth population in those mating restricted orchard, you need to use a really powerful lure so that they can locate the your monitoring trap. So that's why it says 10x. So that means it's 10 times powerful, and it only lasts for 2 to 3 weeks. And then we have other lures, such as this one, gray halobutyl rubber septa. So if the lure is loaded in this rubber septa, it can last for 8 weeks. And usually if the lure says L2, that means long lasting lure. And then we also have another new matrix, which is called PVC. So if the lures are loaded in this matrix, it can last up to 12 weeks, and it's usually denoted by L2P. So all these lures attracts only male because they are based on sex pheromone. But we also have the lure that are based on plant volatiles or pheromones. For example, here CMDA combo P. So here the DA stands for pear ester, that's the plant volatile, and also the acetic acid. So these are loaded in this PVC matrix and also the membrane cup, and it can attract both male and female. And the another lure, which is combo S, is the only difference is the gray halobutyl septa and the PVC matrix. So I'm more interested in this lure, which I use in my master's research. So this lure is Megalure Curling Moth Dual 4K. That means the lure is powerful, it's for curling moth. And dual means it has two components, the PVC matrix and the membrane cup. And 4K means it has 4 chiromone. That means 4 different plant volatiles. And to name them, they are pear ester, acetic acid, diamante, and pyranol linosyl oxide. And it can attract both males and females. The study is conducted in Washington so that it attracts a lot of females. But in Massachusetts, we did attract female, but not as high as in Washington State. And then there's another company called Sentry. They also produce calling moth lure. And yeah, you can tell them by if they are loaded in different material, they can last different weeks. And then we have different type of trap that you can use. These one are the delta shape trap, which can be in the color orange or the white. And then we also have this wing trap. I personally don't prefer this trap because they are very hard to manage. Usually they have this sticky bottom and you have to attach them to the top. And then we also have the bucket trap. There is no sticky liner inside, but you can use an insecticidal strip so that the moth that enters inside can be killed by the insecticide. And this year, we are using the camera trap. So the camera trap is developed by the Barn Owl Technologies, and its shape is like a trapezoid shape. The camera is mounted on the top in this black cylindrical container, and there is a rechargeable battery that lasts up to 12 weeks. And the sticky liner to catch those moths will be housed inside this trap. And then we had this app called Palm Bug Report. And this app is still in beta version, so you can't download them from Apple Store, and it is only available for iPhone, not for Android. But I think in future they will develop that too. So the camera uploads 3 pictures a day, one in the morning, another one at noon, and the third one at evening. And this is how the pictures look like. So here you can see the curling moth trapped in this sticky liner. The picture quality is really good. You can really tell what moth it is. And currently the identification is done manually. So we just check the pictures daily to identify the moth, but they are trying to develop the automated identification. So that, but for that they need more data. So this year we are providing the system more data so that they can identify moth in the future. And they can also develop a graph Right now, we are working. So what are the advantages of monitoring the camera trap? So unlike the Delta trap, which we use to monitor weekly, so this camera trap is like more remote. I can just see the pictures right now, what's happening in the traps, and then it gives us daily capture records and also the temporal activity inside. That means what time of the day, either the moth are more active in the morning or in the evening. And then we also have this biofix establishment, which I will talk later. So this year we have this camera trap in 15 different locations across 3 states, Maine, New Hampshire, and Massachusetts. So before going to the biofix and degradase, if you have any questions, I can answer those.
Actually, I have a question. So the
Sure.
temporal data, it shows you if they're more active in the evening or the morning or the daytime, and then that presumably would be when you would want to spray or treat. Is that why it's useful to ask that?
Yeah, that is also true. And then we are also tracking other things beside the captures, such as the rain is happening or no, or the temperature of the day. So yeah, we want to know when they will be active.
Uh-huh.
They mostly respond to the temperature other than anything. So if the temperature goes low, they will not fly. If the temperatures go up, they will start to fly. I will show that in another graph that is really interesting, like how they respond to the temperature. So, but yeah, we will get a lot of data from those camera trap.
Great, lovely. Thank you. And we'll move on. I don't see any other questions yet.
Sure. So let's move on to biofix and degradase for cording moth. So what is biofix then? So biofix is the time when the page development tracking begins. It is usually, you will consider the biofix usually when there is a first consistent moth captures. Let's take an example. Let's say today, June 3, we caught one moth in the trap. And then let's say tomorrow we are going to catch one more moth. And then next day we catch, let's say, 3 moths. That means today is the biofix because that's our first capture of the whole season. So I can mark today, June 3, as the biofix date. So from that day, you will start to accumulate the degradase, which I will talk a little later. So why does this biofix matter? So usually after when the biofix happens, the biological development of the insect begins. That means we can predict when the egg are going to hatch, when the larva will be active, and when the second generation will start to fly. So all these things can be tracked based on the biofix and the degradase model. So what is the degree model then? So it's a very simple thing. It's just the heat accumulation above the base temperature. For codling moth, they are active when the temperature rises above 15 degree Fahrenheit. Below 50 degree Fahrenheit, they will be inactive, like they will not respond. They will not have any physical development. For example, for codling moth is 50 degree Fahrenheit, but for oriental foot moth, it's less, it's 45 degree Fahrenheit. So usually, oriental foot moth shows early in the season than the codling moth because they have this less base temperature than the codling moth. And yeah, is all insects develop faster when the temperature increases. And there is a formula to calculate the degradase if you are doing it manually. Is the maximum temperature of the day added to the minimum temperature of the day, which is divided by 2. And then you subtract the base temperature, which is 50 degree Fahrenheit. Let's say, for example, on May 13, maximum temperature is 75 degree Fahrenheit and the minimum is 45 degree Fahrenheit. That means 120 degree Fahrenheit total, which is divided by 2. And if you do the math, you come up with the 10 degree days. So that means on May 13, you have 10 degree days recorded. So if you check this, so if you are doing manually, you can do it like this. So let's say on first column, you have date. So May 12, we have no captures. That means we have 0 degree day accumulation. Let's say we have our first captures on May 13. Then we have to calculate degree days from that day. So let's say we have 10 degree day on that May 13, 12 on 14, and 11 on 15. And the total degree day accumulation will be 33 degree days, which you can see in the third column. So moving forward, so how are you going to apply this biofix and degree day model for calling moth management? So yeah, if you are tracking that degree day like that table, so when you reach the 100 degree days, that means the some of the curdling moth eggs start to hatch. Maybe you want to apply some kind of ovicidal around this time, or maybe horticulture oil to kill the eggs. And then around 200 to 250 degree days, that's the time when the larval activity peaks, and you really want to target around this time to kill the larva before they enter the fruit, because once they enter the fruit, it's very hard to control. They will be protected inside the fruit, and they will not be ingesting any material that you apply. And yeah, by combining the biofix and degree model, we have like more precise management, and we don't need to apply the unnecessary chemical without knowing anything what is happening in your orchard. And it also improve the protection efficiency, because we will be targeting this early instar larva or even the eggs. So for myself, I usually use this NIWA website. Is very good. Here, so all our camera trap are located in the place where they already have the NIWA weather station. And so when you go to this website, you just click your farm, or your orchard, or if you don't have the weather station, you can go to the nearest weather station. That will give you roughly the same weather data. And once you are there, you can go to the all tools that will give you a different pest that you want to monitor for. And then I go for the curdling moth. When I click the curdling moth, it will already set up to a 50-degree base temperature. And here, let's say my first trap captures was on May 13. So I'll set up May 13 as my first capture date. And once you do that, it will generate a table, but the table will not show all the degree days in here. It will show you the current degree day accumulation. But if you want to know from May 13, you can also download the CSV, which will download an Excel file. And you can see in that spreadsheet the degree day accumulation from May 13 until June 3, and also the forecast for next 5 or 6 days. So, so how I apply that for the management then? So let's say May 13 is my biofix date, and I have this degree day accumulation on the third column. Um, so my first spray is going to be around 200 to 250 degree days. That's the time when I'm going to spray for the first larval activity. And if you are still catching, let's say, 5 moths per trap per week on around this first spray, then you need to go for a second spray. That means you have a high pressure of curdling moth, and then you have to spray around 500 to 600 degree days. Or if you are not calculating the degree days, you can also go by days, like 10 or 14 days after first spray. Usually what happened with the first generation is that most of the fruits are gonna drop in June drop. There's a phenological stage called June drop, where the apple will drop. So most of the apple that are already infested will drop down, and then you'll have the apple that are not infested in your orchard most of the time. But you really want to control for the another generation, because that will stay until your harvest. So you really want to control for the third generation also. So you want to spray your third spray around 1000 to 1260 degrees to target the second generation. And yeah, if the pressure remain high, definitely go for the fourth spray. And this table is from Michigan State University and Cornell University. So here they show when you can spray against this insect and at what degree it is. So I'll not go through this table, but definitely check this out if you have a problem of coding moth. And here, this graph shows the codling moth population dynamics in Massachusetts orchard from 2023 and 2024. The blue one represents the 2023 and the red is from 2024. And this is the average from 9 different orchards. Here, as you can see that usually the first captures happens around second week of May, and after that they will have a peak close to the end of May to first week of June, and then the population drops down, and then they will have the second generation flying out. And what we have seen in Massachusetts is that we think we have like a third generation, which comes later around August. So once you start catching codling moth, then your traps rarely shuts down. Like if you are doing a weekly captures, and because what happens with the codling moth is that they have a asynchronous emergence. That means they don't come out all at once. They come out different time. So they have like a overlapping generations. So you have like a sustained captures throughout the season. So I'm just marking the potential generations or the flights. And this data is coming from the camera trap now, unlike that, the other graph, which is from the weekly data. This one shows the daily captures. And for some of this location, we did have some biofix, like in the first week from May 13 to May 19. Then this year, we have a very fluctuating temperature, I think. So from May 19 to May 26, it was really cold. And there were some days that went below 50 degrees Fahrenheit. That means no codling moth activity. And up to that prolonged uh, traps are down, we have captures again from 27 to 31 when the temperature rise up. So this morning, we had this meeting with fruit growers and we had to recommend what to do. So our recommendation was, let's say if you have a threshold reached on this first week from May 13 to May 18, you definitely need to spray around later this week because your range of 220 to 250 degrees is going to cross by June 7, which is Saturday. And right now they have this degree days, but let's say on Wednesday or Thursday, it will reach 220 to 250 degrees. And this Wednesday and Thursday is really warm. And in the forecast, I can see that like they have like 20-25 degree day accumulation each day. And then what are you going to do with the codling moth that are flying a little late on this third week? So our recommendation is that go for a second spray at 400 to 600 degree days because these moths that are active from 27 May to 31 May are going to lay eggs much later than the moth that were from the first week. So we are recommending them to spray again at 500 to 600 degree days. So the animation is coming late. So this graph is coming from again from the camera trap, but this is for one location, which is in Clifton. So here you can see how the codling moth flight is affected by the temperature. So blue bar represent the degree day accumulation, and the red represents the codling moth captures. So for this orchard, May 13 was the bifix, and you can see that it has the consistent captures until May 16 and then rise up because the temperature is rising. Then suddenly we had this drop down in temperature and traps almost shut down for a week. And when the temperature start to rise up again, like 12 degree days, 13 degree days, we again have the codling moth captures. But on June 1 and June 2, it was again cold and no captures on those days. And maybe we are going to see the again is picking up this later this week with the high temperature. So you can see how they respond to the temperature. Yep, that's all for the degree days. And if you have any questions, I can answer those.
Yes, we have one question that's come in.
Mhm.
Are you saying that the apple drop needs to be sprayed as part of the controlling the second generation?
Yeah, usually I have not seen growers like cleaning out those apple that are dropped on the ground, but definitely clean it if you have a very high pressure of cording moth, because what we used to do around June drop is that because it's for the research, it's not for the management. We used to collect these apples that are falling on the ground that are either infested by plum curculio or cording moth. We will just bring those apples to our lab and we will incubate them to see what will come out of those, and we will see a lot of insect pests coming out of those. So yeah, I know it's very hard to do for the growers because the orchards are really big and it's like an extra labor to do those things. But yeah, if you have a small orchard and if you are like a home gardener or something, yeah, definitely clean underneath the apple tree. Yep.
Mhm. Great. All right. Thank you very much. All right. So we're ready to move on, and we'll be asking questions again in a few minutes if anything comes up for you.
Sure. So now we are going to like a more management aspect. So this research is funded by the SARE Graduate Student Research Grant, and I conducted this study in 2022. And so the basic idea of this research was to attract the pest to a certain location in the orchard, and then by using some powerful lures. So these lures will attract a lot of insect in that particular location. And when the insect are there, we apply some toxic component. It can be insecticide or some kind of biopesticide to kill them. So the basic idea, and then we term it like the attract and kill. So the objective of this study was to evaluate the efficacy of an attract and kill system for codling moth using a powerful lure and killing them by using the biopesticide, which is dipel. And I think I, I I didn't see any paper on like coding moth attract and kill because I think in the past we mostly had this pheromone lure, which will only attract the males. But this time we had this Megalure CM204K, which is based on plant volatiles. So unlike sex pheromone, these plant volatile are used by moth to locate the food source, their potential oviposition site, and also habitat. So we hypothesized that by using this kind of lure, which are used for like a finding food source, we can gather more moth on those tree, and and this lure also attracts males and females. So if we can attract more female, they will be laying more eggs on those trees compared to other trees. So our idea was to bring more female moth to that tree so that they can lay eggs on that tree, and then apply biopesticide, which is BT, um, based on the degradase and biofix. So this is the basic design of the experiment. So this experiment was conducted in 6 apple orchards. 3 of them were organic and 3 were conventional. So let's say I had this apple block, and I have selected 4 different trees as a treatment. So let's say first tree will get the mega lure, and we will spray BT later on. And then the second tree will get the lure, but will not spray any BT. So we want to know how much damage the moth can cause here. And then the third tree, we have no lure, but we will spray the BT. That will be more like a grower control. And the fourth tree, we will not have any lures and we will not spray any BT. So that will be like a control. Um, and then we will also take data from the adjacent trees to see any spillover effect. And the lures were deployed early in the May, and the injury data were taken at mid-season, around June, before June drop, and at harvest around August. And for each of the 6 orchard, we inspected 800 fruits per cording moth injury. Um, And so the BT application was based on the degree day model. So our biofix date was May 20. And so the first generation spray was done between 228 to 266 degree days, which was around June 1 to 3 on that year. And the second spray was done a little later. We are targeting more like a late larva than the second generation. So it happened around 1568 to 1621 degree days. And here I have divided the chart into organic orchard and conventional orchard. We do have some variability because our replications were very few, 3 for organic here and 3 for conventional here. But still we can see the trend. So for organic orchard, here you can see the T1, which had the lure, and we apply the BT. The injury percentage is around 2.5%. But when you don't spray the BT, your injury will go all the way up to 18%. And if you compare that with just the spraying, because we are using this experiment in a small block, the moth are attracted to this tree where we have the lure. So we didn't see a lot of damage in here. And when you don't have any lure and no BT, we didn't have any significant differences, but you can definitely see the trend here. And for the conventional orchard, there is a trend similar to organic orchard, but the injury was below 5%. And this year we are doing the residual toxicity of the insecticide for against the cording moth larva, and we saw that even after 10 days, this chemical insecticide are effective against this cording moth larva. So we didn't see any conventional any damage like reaching the threshold in the conventional orchard. And for the harvest data, we didn't have a lot of fruit compared to the June because a lot of fruit dropped, and we didn't see any significant differences. But you can definitely see in organic orchard when you have lure and you don't spray, you have 9% injury. And if you compare that with the conventional, is very low, but there is a trend. And so in conclusion, we can see that the megalure can attract cording moth to certain locations. And then based on the degree days, if you apply Bacillus thuringiensis in the time when the larval hatch is happening, then you can also kill the larva by applying the BT. So yeah, so that's all for the attract and kill. And if you have any questions, I can answer those.
Yes, we have one question. How are codling moth emergence times changing over the years, for example, over the last 50 years? Do you have that data?
So per ourselves, so we have been tracking the cording moth from when I'm here, 2020. I didn't have the past data, and it's very hard to find the data on like how or when they are emerging. Usually, we have the date saying like, okay, they will show up around bloom, and we don't know exactly. And if you track the apple phenology, it's always different. Like sometimes if the weather is too cold, you'll have late bloom. If the weather is high around April, then you have the early bloom. So it's really hard to track, and it keeps changing. So sometimes like we have the biofix around May 20, and sometimes we have biofix around May 8. So it's very hard to say the exact biofix when it's going to happen. So it's important to track the degree days. So that's the only way, because for this year, like we had the period when the temperature went below 50 degrees Fahrenheit. So no cording moth activity. So our degree days is pushed a little back. So yeah, I hope I answered the question.
Yeah, they're great. And then we have a couple of other questions. Did you get any data showing the effect of the lure trees on the rest of the orchard?
Oh yes, I forgot to include that adjacent tree data here. But yeah, we did see the trend. So they are attracted to the nearby trees as well. And although we didn't had any significant differences on those, but yeah, they are definitely go to the nearby trees if you have the lures in one tree.
All right. And Clem Clay said, would you recommend that an organic grower use the attract and kill, or would they be better off just spraying BT at the correct time across their whole orchard?
Yeah, I think yeah, hi Clem. Yeah, it's a little bit challenging for organic grower because the material that we have that is only effective for very precise period, unlike the conventional orchard where the materials can last long, like their effect can last until like 10 days or even more than 10 days. So yeah, tracking degree days is really important. Um, and if we can spray, I think we need to have a multiple spray of materials such as Bacillus thuringiensis, because with the weather, if it's rainy, like if let's say if it's gonna rain in next few days, then the it's gonna wash off. So yeah, definitely track the degree days and also the moth activity, like the flight activity, and then maybe you need to go for a second spray.
Okay. All right. I think that's all the questions we have for the moment. So let's carry on.
So yeah, so this study is again the part of the SHARE grant. So this study was conducted inside the lab. So here we were testing the residual effect of Bacillus thuringiensis against cording moth larva. So before going to the research, so how BT kills the cording moth larva? So in order for the BT to kill the larva, so the larva needs to ingest the BT component. So unlike so human stomach is mostly acidic. That means even though we ingest the BT by mistake, it will not have any effect on us because bacteria doesn't like the acidic condition. But unlike us, the moth larva or any caterpillar gut is alkaline. So whenever the BT toxin goes inside their gut, it will get activated. And once the toxins are activated, it ruptures the cell wall and the gut component will enter the body cavity. And that way they will be paralyzed and they will stop feeding. So even though if you apply the BT, you will not see the cording moth larva dead right away. It will take some time for them to be dead. And they die about like 2 to 5 days after they ingest the BT. They will turn dark in color. So let's go to my study here. So for this study, I used two larval instar group. So first to two instar is one group, and they are like 4 to 10 millimeter long. And the second group will be 3 to 4 instar larva, which is 11 to 16 millimeter long. And I didn't use the fifth instar larva because they are very hard to kill. And for this experiment, I collected the apple that are like 2 centimeter in diameter. And as a kill component, I use the BT at the recommended dose of 2.38 gram per liter. And for the experiment, I sprayed the apple on day one, and I exposed them to 10 cording moth larvae. And I kept some larvae for 3 days, kept some fruits for 3 days, and then I exposed them after 3 days to the cording moth larvae. And similarly, I did it for the 7 days. So I use this glass container and then I put one fruit that is sprayed with BT, and then I expose like 10 cording moth larvae inside here. And the mortality was taken at 24 hours, 48 hours, and 72 hours. And here, the first graph, it shows the 1 day after spray. So the mortality here you can see, although in 24 hours they have ingested some the BT toxin, they were not dead, they were still moving. And after 48 hours, they stopped moving, but they were not dead. Like if you touch them, they will move. but they were like in a morbid condition. And after 72 hours, 3 days, they were completely dead. So here you can see that the first to second instar larva, it has 90% mortality, and the third to fourth instar larva have 65% mortality. And I do have some mortality in the control, but that is not because of anything. It's the cording moth larva, they are cannibalistic. So they will try to eat each other. So once there's only one fruit for them to eat, so they were kind of eating each other as well. So the mortality is coming from there. And so for the 3 days after the spray, the mortality decreased. The first to second star has 65% mortality, and 3 to 4% has below 50% mortality. And similarly, for 7 days after spray, the mortality is less than 50% for all of the thing. And the important thing to notice here is that these apples, after 3 days after spray and 7 days after spray, were inside the lab condition, more inside the greenhouse. So they were not affected by any rain or like a direct UV rays. So that's why we had some mortality, but in real life condition, maybe they will only be uh, efficient in like first day or second day. And if there is a rain event or something like that, it will wash off. So this was in the lab condition. So just to note that. So in conclusion, BT can kill up to 90% early instar calling moth larva within 3 days. And dipel is more effective at killing younger larva than the older larva. And I think that's all for um, the residual toxicity. And here, I would really like to thank all the growers for giving us their orchard block to do experiment. And I would also like to thank CropView, Barn Owl Technologies for giving us the camera trap to do some test. And then Stockbridge School of Agriculture, UMass Amherst, and State Grant for funding my research. And thank you so much. And if you have any questions, I'm happy to answer.
Lovely. Thank you so much, AJ. We have one more question that has popped up, which
Mhm.
is from Jeremy Delisle.
Uh-huh.
Do we know how long codling moth larvae are typically outside of the fruit feeding and ingesting BT?
Oh, so once the eggs are laid, they had to eat. So they will first start to eat the skin of the apple. So that's the time the BT needs to be in your hands. Otherwise, if they enters inside and if there is no BT or no any not any insecticide, if they enters inside the fruit, it's very hard to control. So you are targeting like a egg hatch. So that's why the degradase is really important. And if you are using a very toxic material that can last long in your crop, then you are definitely protected for a long time.
Mhm.
But if you are using material like BT, then you should really, really track the degradase and know when they are going to hatch.
All right. Okay. I think that is all the questions that we have. Um, and thank you, AJ. So we'll carry on. We'd love to get some feedback from you. Same thing. We have 3 questions and should pop up on your screen. And so we'll just take a moment so that you can answer those questions for us. And I'll be quiet while that's happened. All right. So I will share the results. So you can see there is a shift there that it's moved to somewhat, moderately, and very knowledgeable, and based on your presentation. And how knowledgeable are you about the biology? And there's also a big shift there after the presentation. And as a result of this webinar, how likely are you to increase your implementation of IPM? And there are quite a lot of people there. There's like 60, more than 60% in very likely and extremely likely. So good job, AJ.
Thank you so much.
Oh, great. All right. So we just have a couple of things to go over before the end. We do not have any webinars scheduled for the summer. We usually take a break over the summer just because folks are in the fields, and but we often pick up in the we usually pick up in the fall. So look out in August. You should see some new toolbox webinars coming out for September, October, November, that kind of time frame. If you would like to be in contact with other people who are interested in coddling moths and apples, a great way of finding colleagues is to post a profile about yourself on this website here. And you can also find colleagues who have posted their profiles there. So I don't know if AJ is on there, but I know lots of people are, and it's a good way to find each other. And as I mentioned earlier, there is a recording of this webinar, and I will send you an email, and it takes us about a week just to edit it and get it ready for you. And it will be up on our website, and you can go back and watch it as many times as you like. So I believe that is the end. And so that leaves me to say thank you very, very much,
Thank you so
AJ,
much
for
for that.
I mean, that was a great presentation, really interesting research, and congratulations on the award. And thank you for all your work, all your hard work in being able to put that together and do the work. So, and yeah, a lot of other people are saying thank you, and they appreciate it
Yeah,
too. So, all right.
yeah,
And with that, I will bid everyone adieu to go and enjoy a beautiful June afternoon. Okay, bye bye.
sure. Thank you. Bye bye.